Here's sample test number 1, problem number 5. While exploring the cave, a spelunker starts at the entrance and moves the following distances. She goes 75 meters north, 250 meters east, 125 meters at an angle 30 degrees north of east, and 150 meters south. Find the resultant displacement from the cave entrance. Let's treat this as a vector problem. So let's take a look at this. Here's east, here's north. Our first vector is 75 meters north. So let's call that vector A, 75 meters north. So we say A as a vector is 75J meters. And then our second vector is 250 meters east. Let's not necessarily draw this to scale, but it's 250 meters directly east, and that is vector B, and that is 250I meters. And then our third vector is 125 meters at a direction 30 degrees north of east. So you go east and then you go 30 degrees north of it for 125 meters. And that's our vector C. This one would be. So C is equal to 125 cosine 30I plus 125 sine 30J. And if we figure these components out, 125 times cosine of 30 is 108.3 I, and sine of 30 is 1/2, so this is going to be 62.5 J. So that's our vector C. And then our final vector is D, which is 150 meters south. So if we go 150 meters south, maybe it's something like this. And so we'll say D is strictly a negative 150 J, because it's totally in the negative J direction. Meters. This is meters too. Alright, so there's our 4 vectors, and our resultant vector is going to be the vector that adds these 4 together. So our resultant vector is going to start from our original origin, come straight to our final destination at the end of D. So our resultant vector R is equal to A plus B plus C plus D. And so in terms of vectors, that is going to be 75J plus B, which is 250I, plus C, which is 108.3I, plus 62.5J, plus D, which is actually a minus 150J. Well, we add up all of our I components together and all our J components together, so we're going to have 250 plus 108.3 is 358.3I. And then for the J, we're going to have 137.5 minus 150, which is going to be a negative 12.5 J meters. That is our resultant vector. That would be our resultant displacement if you just want to list it like that. But let's find the magnitude of that. Another way to describe displacement is magnitude and direction. So our magnitude of this resultant displacement would be 358.3 squared plus a negative 12.5 squared, all that square root. And that's equal to 358.5 meters. That's the magnitude of our resultant displacement. And our angle, let's just find this angle right here. So we'll strictly go for the positive of it. Inverse tangent of our y over x. So inverse tangent 12.5 over 358.3 is 1.998 degrees, or we'll just say 2.00 degrees. Now the direction is going to be south of east, as we're looking at. So we didn't want to put the negative sign in there because the calculator wouldn't know which component was the negative component. So we strictly went for the angle, pure angle, and then we defined it afterwards by knowing that we were going into the fourth quadrant down there. So it's 2 degrees south of east with a magnitude of 358.5 meters. So that's our answer for the resultant displacement from the cave entrance.